Hello and welcome to this quick review of the nucleophilic addition mechanism involving the cyanide ion. Like it says in the grey box, please ensure you've done your independent study or some notes on the nucleophilic addition mechanism before watching, as this is an application of that particular mechanism. Throughout the clip I'll leave the two key definitions from the glossary in the textbook in blue and make reference to them as we go through the mechanism. So let's start by having a think about the cyanide ion and how it's put together, because it's important to understand this so that we can see sense in the mechanism a little bit later on in the clip. So the cyanide ion has a triple bond between carbon and nitrogen with a lone pair situated on the carbon atom. So it might be worth pausing the clip and trying to sketch a dot-cross diagram of this ion, and then resuming the clip when you think you've worked it out. So you start off by allowing a decent overlap of the shells, because you know you have to include a triple bond, in other words 6 electrons, 3 pairs. So now you can put in the triple bond. So taking care of nitrogen first, you make sure that you've got 5 electrons in the outer shell of nitrogen from its original number of electrons, and now added to that are the 3 that it's sharing with carbon, so it's got 8 electrons in total. So nitrogen's octet is complete. Let's do carbon now. So carbon only has 4 electrons of its own, 3 of which are already involved in the triple bond. If you notice on the left of the screen there's an unpaired electron, but this needs to be part of a pair which is donated to form a data covalent bond. So this is where the extra electron that the carbon has gained to form the Cn- ion. So although we have the number of electrons in the outer shells for each of the 2 atoms, one of them needs to gain an extra electron. So you can now see that there's an extra electron on the carbon atom, so it carries the negative charge of the overall ion. So we've got a triple bond between carbon and nitrogen. You've got the negative charge on the carbon and the lone pair on the carbon ready to go. We have 8 electrons per atom in total, so the valencies have worked out. So the whole ion now carries a negative charge, but the negative charge itself is centered on the carbon, as you can see in the blue version of the ion that I've drawn. So now we can start thinking about how it could behave as a nucleophile. So a nucleophile donates a pair of electrons to form a dative covalent bond. The way this is shown in terms of mechanisms is by a curly arrow like that. So what that means is those 2 electrons on that carbon are now forming a dative covalent bond. So you might get a structure like that, for example. The important thing to notice is a new carbon-carbon single bond is formed. So the formation of this new carbon-carbon bond is an important part of cyanide's use in organic synthesis, which we'll look at when we do the nucleophilic addition mechanism in a minute or so. So, although the nitrogen still carries a lone pair, this lone pair doesn't get involved in the bonding aspect of cyanide's role in this particular mechanism. So to reiterate, it's the lone pair in the carbon that gets involved. And because the carbon carries the negative charge, like we've already said, that means that when you draw your curly arrow, you can also draw it from the negative charge if you wish. So this is also acceptable in mark schemes, but starting the curly arrow from between the lone pair and the carbon is slightly more precise in my opinion. The reason I say this is because it says exactly which electron pair is moving to and where. So let's now look at the mechanism itself. So I'll use methanol for simplicity to keep things nice and easy to understand. So the lone pair on the carbon on the C double bond end is attracted to the carbon that's partially positive, the electron deficient center in C double bond O. So basically this matches up with the description of the definition of a nucleophile that you can see at the top of the screen. So the carbon's your electron deficient center or atom. So the next thing to happen is the pi bond breaks between the carbon and the oxygen in the C double bond O, and that lone pair ends up on the oxygen, making it negatively charged, which allows an H plus ion to protonate this intermediate that's formed. The H plus ion is formed by the formation or synthesis of HCN, the HCN being the product of the reaction between sodium cyanide and sulfuric acid. It's important to point out that HCN is very toxic as a gas, so if we make it in the lab, we're putting ourselves in danger. So we use this method instead, which produces it in aqueous solution. So once this reaction happens between the proton from the HCN and the oxygen that has a negative charge in the intermediate, that produces a final organic product, which is about to come up on the screen. This final organic product is an alcohol group that's attached to a carbon-carbon chain that then has a nitrile at one end. So this new compound is called 2-hydroxy-ethane nitrile. So let me explain the name a little bit. You can see it's got an OH group in one place and a C triple bond N in the other. Now clearly in the middle there's a carbon chain. That carbon chain has 2 carbons in it, so that's where the ethane part comes from. At the same time, the most reactive part of that is the nitrile. So that nitrile gets assigned carbon number 1. So that means counting from carbon number 1, the OH group is attached to carbon number 2. So therefore we call it 2-hydroxy-ethane nitrile. So this is a very important group of compounds because it shows that a carbon-carbon bond has been created that wasn't there at the beginning. So the formation of nitriles is a way of extending the carbon chain by 1, as you can see in the numbering on the screen at the moment. Right, this takes us pretty much to the end of this clip, which just summarizes the nucleophilic addition mechanism and the basis of the formation of the cyanide ion. So just to summarize, a nucleophile has been provided by HCN, and HCN is added to the aldehyde, the H in the second stage and the CN in the first stage. So the dative covalent bond, once more, is between the carbon in the C triple bond N and the carbon in the C double bond O. And in the second stage, the hydrogen from HCN is added on to the intermediate to create the OH group, or the hydroxy group, 2-hydroxy-ethane nitrile. So, once again, thanks for your time, thanks for listening, and until next time, see you soon.